All right, let's take a look at question one. What is question one saying? Okay. Which of the following statements about objects is correct? An object defines only the methods for a class. Let's look at that A. Okay, so there's a couple things that are wrong about A. It says an object defines only the methods for a class. The first thing we always have to remember, as we've talked about a lot in class, every object has two things, right? Every object has the data and the behavior, right? And data, that's the instance fields. Behavior, those are the methods. Those are two things that are inside every object. And A says there are only methods. It's basically saying ignore that there's any data. There is no data. So we know that's wrong. It has to have methods and behavior. The other thing wrong with A is that it says an object defines. Objects don't define anything. Classes are the things that define the object. Remember, classes are blueprints. So actually what we should have is these two words, object and class, should in fact actually be switched. If it said an object defines, sorry, I should say a class defines blah, 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 that would be correct. But it's not an object defining. Classes define what are inside the objects. What are inside the objects? 1 and 2, data and behavior. Okay, let's look at B. Every object has its own set of data and a set of methods to manipulate the data. Ooh, I think that sounds just like what I said. Data and methods. Okay, that's looking good. Let's put a happy face next to it and move on. Okay, C. An object is a sequence of instructions that perform a task. No, that in fact, if we take out the word object and we replace it with another word, a word of method, that's the definition of a method. A method is a sequence of instructions that perform a task, right? It's a named sequence that we've given the name to it, and that's just a sequence that repeats itself whenever it's called and does a job. So it can't be C, because C is describing a method. Okay, D, all entities, even numbers, are objects. Okay, this one we know is wrong because it says even numbers. And we learned back in the beginning of this course that we have things called primitive numbers, and we have int and double. And we also learned that we have a primitive char for characters. And the reason they're called primitive is because they're the exact opposite of this. They are not objects that have data and behavior. They are just a simple number holding up space inside memory. Okay? So they're the exact opposite of objects. So D is wrong because not all entities are objects. Okay? We have these primitive data types, and their sole definition is they are not objects. That's how we can tell them apart from objects. So far, the only thing that's got a smiley face is B, so that is the correct answer. Correct answer is B. Okay, let's move on to question 2. Which of the following statements about classes is correct? So we're going to be focusing on this word. So we're thinking about classes. A class is an object that can be manipulated by a program. Okay, so the problem with A so far is that it says a class is an object. As we just discussed in 1, classes are not objects. Classes are the blueprints for creating those objects. So no, class is not an object that can be manipulated. Classes are just the blueprints for creating objects, and the objects are the things that we are working with and manipulating and changing. So nope. A, no. B, a class describes a set of objects with the same behavior. That is sounding interesting, and I kind of like that, so I'm going to put the smiley face there. C, a class is another name for a method. No, there's just nothing right about that. We've never discussed that. That never comes up. A class is not another name for a method. No way. B, a class can contain only methods. Well, we just discussed up in number 1 that a class must contain two things. 1, the data, right, which is also referred to as the state or even the attributes or properties of the object. And 2, it also must have the methods, which are also referred to as behavior, right? So we know that we've got to have those two things inside every single object. They are both put inside of it. Okay, that's the whole point of object-oriented programming, is that we have two things encapsulated inside of it, data and methods. So a class can contain only methods. This is not the object, it's the class. It's the blueprint that's creating that. But no, a class has to have the methods in there, and it also has to have the instance fields that tell you how to store that data. So D, no. If we look back at B, the one that had the smiley face, a class describes a set of objects with the same behavior. Okay, that makes sense, because remember, if this is my class over here and it's describing all the data, the state, and the methods, remember it's a blueprint and it's just being made, it just makes objects, different instances, lots of objects, another object, another object. Each one of those objects, let's say we made an A, a B, and a C, those are three objects coming from this class. All three of them, A, B, and C, they all behave in the exact same way. Why? Remember, another word for method is behavior. Behavior describes how it works, what it does. So every single one of these objects have the same behavior because they have the same methods inside. They have the same data or instance field inside. The only thing that's different is the actual number that's being held inside that instance field. Okay, so the answer for 2 is also B. All right, good job, B. 2 questions and 2 B's. All right, let's move on to question 3. What is question 3 saying? Question 3. Which of the following statements about classes is correct? So again, we're talking about classes. When programmers work with an object of a class, okay, they do not need to know the how the object stores its data or how the methods are implemented. Okay, so we're dealing with a question about implementation. Okay, so whenever you come across this word implementation, always remember that classes and their classes and their methods inside, everything is from curly bracket to curly bracket. And all that code that's inside, like especially inside a method, because all 4 of these options here seem to be talking about, methods, okay? So method implementation is always inside the curly brackets, and it's always hidden from other objects. The other objects cannot see inside the curly brackets, okay? And what we call those 3 dots that I've written here, the code that's inside the method, that's implementation, right? So the implementation inside of a method is never known by the other objects, okay? They only can see the public statements, the headers of the methods. So in every case, how the method is implemented is always hidden, okay? We do not know how methods work. We don't know how they work. All we know about the methods is what they do, okay? So we don't know how, we just know the what, okay? What does this method do? It gives me the smallest of 2 numbers. Oh, how does it do that? I don't really care. All I care about is that it gives me the smallest of 2 numbers, okay? So when we're always thinking about methods and their implementation in the context of object-oriented programming, the idea is the how is hidden, okay? The implementation is hidden. I don't care. I don't need to know how you do your job, buddy. I just need to know what you do, okay? That's the idea with methods, okay? And the other part of this question, so this part, let's go back to this. It says they do not need to know how its methods are implemented. That's true. I don't need to know how those methods are implemented. So that part of this answer is correct, but it's a 2-parter. It says on this side, this side of it, it says, I do not need to know how the object stores its data. So again, talking about methods, objects. Objects always have those 2 things, right? It has the data, right? It has the methods. And we just talked about how methods implementation, I only care about the what, okay? I only care about what you do, buddy. I don't care how you do it, okay? In number 1, the data. What do we care about with the data? We care about how that object stores the data, okay? We need to know how it does that so that when we are calling and using the methods or using the object, we need to know how that object is holding the data inside so that we can send it the correct data, right? If you have a number that's an integer, that's a big difference than you have a number that is a double, right? If I send you something that's a double and your instance field can only hold an integer, I have a problem. That big double cannot fit inside that integer. So I do need to know how an object stores its data, but I don't need to know how the method implements itself. I just care about what the method does. Okay, so these are the two big things we're looking at here. Object-oriented programming, it puts the data and the methods inside each object. Each object has its own copy of the methods, has its own copy of the instance fields. And in terms of how those methods are written, we only care about what the methods do. We're not so much concerned about how they are implemented from an object's point of view, right? If one object's looking at another object. As a programmer, sure, you care because you're the one writing the implementation, but we're talking about information about the class and the objects that come from those classes, right? So we don't really care about the what for methods, but we do care about the how for data. So that's the problem with A here, is that A is saying we do not need to know how the object stores its data. Okay, in fact, that is wrong. We do need to know how it stores its stores its data. So A, it's half right and half wrong, so it can't be A. So if you look at B, it says the programmers work with an object of a class. Okay, they must understand how the object stores its data. Okay, well, that sounds good. That's what I just said, how. And how its methods are implemented. Oh, sorry. No, that says we need to know how it's met. No, we don't need to know how. Okay. We don't. Sorry. So we got the opposite is opposite of A. Okay. C, when programmers work with an object of a class, they must understand only how the object stores its data. Okay, I guess that sound promising because we do need to know about this, right? We do need to know about this. We don't really care about how happens with the methods. So that's sounding pretty good. That kind of matches, even though it only talks about one, it does match. When programmers work with an object of a class, they must understand only how the object's methods are implemented. Well, no, I just said that. No, so it can't be this B, which should have been a D. So the answer is C. We only must understand how the data is stored so that we can give that object, when it's instantiated, we can give it the correct data. All right, that was a long answer, but an important question, just to understand how things are put together. Okay, let's get into some implementation questions here. Okay, question 4. Okay, so you've created a motorcycle class which has a constructor with no parameters. Which of the following statements will construct an object of this class? Okay, so this is basically a question asking you, how do you create an object? What is the proper code? And our class is called motorcycle, so we're going to be creating motorcycle objects. Woohoo! A, let's look at A. Motorcycle, my bike. Okay, so the key for this is that we're making, or the key to this question is that we're making motorcycles and it has a constructor with no parameters. So notice it has a constructor. Okay, so that means we want to be calling the constructor with no parameters. There is nothing wrong in A syntactically. Like, this is acceptable. This would not cause a red wavy line in your IDE inside BlueJ. However, this doesn't actually create the object. No object is instantiated from this. What this statement says is motorcycle, my bike. This is basically saying, hey, I'm going to at some point have an object called my bike. I'm going to have a motorcycle somewhere along the lines, but right now I haven't made the object. So compiler in this instance will create my bike. And what does my bike point to? What does it reference? It references nada, nothing, okay? There's nothing here, okay? It's not pointing to anything. All we've made is basically a sign that says, hey, I have my bike. Where is it? We actually haven't made it yet, sorry. It's coming down the line. So there's nothing wrong with doing this, okay? But this actually doesn't create an object, okay? So even though A has no error, it's not matching what we're looking for in the statement in the question that we're looking at. So let's move on to B. B says motorcycle, my bike. So again, it's the exact same thing we have as so far with B above. And then we have an assignment operator, new motorcycle. Ooh, this is looking promising because we have the reference, which is my bike has been created. And now on this side, we have new. Okay, and as we know, new, that's the operator, that's the actual line of code, those three little letters, that's the thing that actually, boom, makes the object. And motorcycle is the constructor from this class, right? Because we're a motorcycle class, and it's got no parameters inside, meaning it's a constructor that just creates an empty object with all of the default values. And ooh, that matches what we're saying here, something with no parameters. So that's got no parameters. This is looking pretty good. So I'm gonna put the happy face on this, and maybe we'll come back to it, and that might be our answer. But let's keep going with C. My bike dot new motorcycle. I don't even know how to describe how this one is just wrong. There's just no, okay, because my bike is an object reference dot. Remember, that means go inside the object and do something, and this would mean we would have to have a method called new, and that method's parameter is a motorcycle. And that's just no. No. Sorry, no. That's not how we make an object. Okay, go down to D. D is kind of trying to do the same thing, and it's just basically mixed up my bike and motorcycle. And again, this is not how we do it at all. There's all sorts of wrong with C and D. Okay, the answer is only B, right? B has created an object called, or an object reference called my bike, and it is pointing to an actual object of a motorcycle, right? We've got the motorcycle, and it's matching all the rules here for creating an object. Constructor, remember, has to have the exact same name as the class, which we've set up here is motorcycle, so that matches the exact same spelling. We've got the bracket for a method call that has no parameters, so that's matching. We got the new operator, which actually creates the object, and we've got the reference over here called my bike, which will point to the motorcycle object. So yeah, the answer in 4 is B. Let's move on to question 5. Question 5, a short one. It says, when an object is created from a class, the object is called a/an blah blah of the class. Okay. So this is basically talking about if I have all of my class code here. I've created a class, it's got all my methods and my instance fields, and now I'm actually instantiating, creating objects. So I've made 1, I've made 2, I've made 3. So if I made like an A object and a B object and a C object, I've got my 3 objects floating out in space. Okay, what do we refer to these objects of? Do we call them a child of the object, a constructor of the object, an instance of the object, or sorry, instance of the class, my mistake going through all of these, or a subclass of the class? Okay, so child, no, we don't call these child. This object is a child of the class. No, it's not a child. Okay, constructor. No, it's not a constructor. A constructor is a method that's written inside this class that is used when we're actually creating it. So no. An instance of the object. That sounds about right. Subclass, no. Child and subclass are real things, and we'll learn about them later, but not now. Constructor, that's a real thing, but it's not what we call objects. We've never called an object a constructor. It has a constructor inside the class, but it's not a constructor altogether. Okay, and the answer is C. It's an instance of the class, because just like in language, like real world English, right? Each one of these is an instance of that. Like this is a version of that. B is a version of that. C is a version of that. Like it is an instance of this. Okay. If this was a car type, right? If this was a car, I would say this is a car, this is a car, this is a car, right? I have 3 cars. Each car's, okay, it's a different instance of this car class. Maybe this is a blue car, this is a red car, a green car, but each one of them is an instance of cars. I have a car. Okay, that's the idea here with instance of. Okay, so 5 is C. 6, each object of a class has a separate copy of each what? Okay, So we have each object of a class. Remember, a class has its methods and its behavior. It's methods and object. Okay, those two things. So if each object has a method and objects, let's go through this. Okay, let's start at D just for fun. D, class. Each object of a class has a separate copy of each class. No, that's just all sorts of no, because an object is an instance of the class. It is not the actual class. It's its own thing. So no. Each object has a class separate copy of the constructor. No, does not have a separate copy of the constructor. Remember, the constructor is used to create that object. Okay, instance variable. That sounds pretty good. And method. Ooh, I don't know. Is it method or is instance variable? Okay. So the big thing is to realize with instance variables. Okay. Basically what happens is if this is my class, and then in my class I have my, let's say I have private int num. Okay, so this is my class declaration, and down here I have my constructor and all my methods. Okay, and this is my whole class here. When I'm instantiating an object from this class, okay, the methods all get copied over, right? Boom. As well as its own copy of this variable. So this variable, okay, here's my my object. It's basically a photocopy machine, if you could think of it that way, and it has its own set of these pieces of data, so that the data over here can be thought of and used separately than different object. Okay, so they are its own copy of it. So the thing to remember when you're dealing with, the answer is B, when you're dealing with objects and object-oriented programming, the instance variables are copies, just so that the objects can have its own copy, its own pieces of data to work with, rather than sharing pieces of data amongst each other. Okay, so when you see the word copy, objects have a copy of the instance variables. Okay, 7. Let's move down to 7. Move along here. Which of the following is not, capitalized here, part of the declaration of an instance variable? Okay, so instance variable. I'm just going to declare one here, and then we'll match up which one of these is not part of that. So when we declare an instance variable, we are always writing private, because we don't want anyone to just have access to it. So private int num1. Okay, so I've written 3 parts to this, right? I've got a name, I've got a data type, okay, and I've got this word private here, which is a modifier set up to private in this case. There's only private and public, and that's basically controlling access, right? So I've got the 3 parts here. I've got the modifier or the access level, right? Controlling who gets access to this, private or public. Then it's just like any other variable. It's got the 2 parts, the data type that I'm using and the name of this object. So now I can go through this A, B, C, D and figure out which one of these is looking not so hot. Remember, we're thinking about the not. So the return type, did I write a return type? No. So it's looking good that the return type is the answer, but let's keep going down. A modifier specifying the level of access. Ooh, that's right here. Okay, so can't be this because that is correct. C, data type. Oh, it's here. And D, the name. Oh, it's here. So the only one here that doesn't belong is A. And in 7, B, C, and D, that's actually going across of what needs to be in a instance field. Okay, so the answer for 7 is A. Let's go down to 8. Consider the following code snippet. Public class coin, okay, and we have private string coin name, public string get coin value. So this is private string coin name, so we're going to say this is an instance field, right? Instance field, And here we just have get coin value, which we can see is returning a string. So this just looks like a regular old method. It's not a constructor because it doesn't have the same name. This is just a getter, which we've learned is called also an accessor method. Okay, so it's just basically get as the coin value. So whatever this name is, it's going to have a value associated with it, such as like a quarter is 5 cents, a quarter is 5 cents. Wow. Quarter is 25 cents, nickel, 5 cents, dime, you get the deal. So which one of these statements is correct? Okay, the get coin value, and if we look at very quickly, just scanning down, all of these are talking about the method. So it seems to be a question about what's the deal with this method. So the get coin value method can be accessed by any user of a coin object. That might sound a little good. Well, we'll keep going, right? It is set to public, so that might sound pretty good. Okay, the next one, the get coin value can be accessed only by methods of the coin class. So what that says is that, remember, this is inside the class here. We're looking at class code. If this creates an object of this class, the coin class, so I've got a coin here, and I've got, let's say this is object 2, and it's also a coin. So I've got A and B coins. Okay, it says the method can be accessed only by methods of the coin class. So that means not even inside the objects, inside the actual class, the blueprint. That means only the methods inside here are able to talk to each other. So that makes no sense because we're designing these to have objects talk to each other and access each other. So no, it doesn't look good for B. C, the coin value method can be accessed only by methods of another class. Okay, so that means I have another class over here, and these guys in this coin class can only be accessed from another class outside. So again, no. We're not talking about access from classes. We're usually just talking about objects, right? And let's keep going. D, the coin value method cannot be accessed at all. Well, that doesn't make sense. Why would I make a method that can't be accessed by anyone or anything, right? I do want to have some access in a lot of these, either by something else in the class or by something else in the object. So no, okay? And the keys with B and C, of course, is that it says only, okay? Meaning no other person, or I should say no other object or class can talk to these things. So in certain instances, we can set this up so that only the object can talk to itself. But no, this is not a standard thing. And D is just why. Why would we make everything closed off and private? What would be the point of that? So it's all sorts of wrong for D. So the only thing that's got the happy face left is A, and that's the correct answer, right? We're making our methods public here so that this object here can access this guy's, and this guy's can access this one's if we allow this, and they can see what's there. Okay, so the answer for 8 is B. Let's go down to 9. Consider the following code snippet. Public access vehicle, so we got some kind of vehicle class here, and it's got set vehicle attributes and get vehicle attributes and get model name. So we've got 2 getters and 1 setter, and we've learned that setters refer to mutators, right? Because mutate means it's changing. And getters, we have learned to refer to them as accessors because they just allow us to access the data. They return just what's inside that instance field associated with the model name or the attributes of the vehicle. And the mutators allow us to set or change attributes inside the vehicle. So this seems to be a question down here about accessors and mutators. So I've just written that out, and so we'll just see which one matches. So assuming that the names of the methods reflect their action, okay, which of the following statements about the class is correct? So what do we have? A, we have set vehicle attributes is an accessor. So we just said sets are only mutators, so that's wrong. It can't be an accessor. Setters are mutators. So we have a setter here that says mutator. Ooh, that sounds right. C says get vehicle attributes is a mutator. So get is an accessor. No. And it says this one, get model name is a mutator. No. Getters are accessors. So the only one left that's got the happy face is B. 9b is the answer, because that is true. Setters, right? Setter methods, when we look for that word set, that means it's a mutator. It's changing. It has the ability to set a new value inside an instance field or somewhere in our object. So setters are mutators. Okay, let's move down to 10. Just scroll it up here. Okay, so 10. A method is a class that returns information about an object, but that does not change the object. Is called what? So we got a method that returns information, but it does not change the object. Okay, so we have, let's say, an object here. We call the method and it just returns something, but the state of that object has not changed. It's still the same. That's the definition of what I just mentioned in the question above. That's an accessor, right? Just access the information, but don't change it. Remember, accessors, okay, just give me the data. Those are the getters, okay? The opposite of that is a mutator, and those are change. Those are our setters, okay? So what do we have here? A, mutator. Mutator means we're changing, so no. Accessor, that's looking good. I think that's just what I said. Accessors get the data and just return it to you. Void, no, that means your method's not returning anything. Constructor, that's the kind of special method, so no for C and D. The only one that's got the happy face is 10B. Okay, let's move on to 11. Which statement calls a constructor with no construction parameters? Okay, so we had a similar question before. How do we create an object? How do we do that with a constructor with no parameters? So remember, no parameters means we're looking for something with bracket next to the constructor, right? And there's nothing inside. So let's go to A. It says circle C equals new circle. That's got the brackets, and that's looking good. I'm gonna put a happy face there. Circle C equals new circle. Well, this one does not have the brackets, so that means circle. Remember, that's how we know it's a method. There's brackets there, so this one has no brackets, so no, can't be that. Circle C equals circle. Well, we have the brackets, but we don't even have a semicolon, so there's no semicolon. That doesn't work. And D, a call to a constructor must have construction parameters. No, it doesn't. It can, but it doesn't have to have, so that's wrong. Okay, the only one with the happy face over here is A, and that is true. That is correct. The answer for 11 is A, right? Because here we have a reference. Remember, this is the reference, so I'm making a reference to an object called C. So the reference is a C, so it's pointing to an object of what type? Well, here's the new operator, so that actually creates the object. Boom. And the type is of type circle. Okay, so there's the constructor, so that actually constructs and calls the constructor with no parameters, no data. So this guy will be instantiated, created with all zeros for its ints and its doubles, and a null for strings. Okay, so 11 is A. That's how you correctly call a method. Sorry, correctly create an object with no parameters. Okay, so 12, consider the following code. Public class vehicle. Okay, here we have a constructor, okay, because the names are matching. Then we have instance fields, okay. If we look at the instance fields, we have a string and an int, okay. And then our question is, which statement reflects the action performed when the constructor to vehicle is called? So let's look at the constructor beforehand. We have public vehicle, okay, the names are matching. It's got no parameters, and inside we can see that it's just bracket. The ... here refers to the rest of the class. There's nothing inside of that, or there is other things down below, but we don't care because the question's only asking about the vehicle constructor. So here we have a situation where we have bracket. There is nothing in between. That means this constructor sets these two instance fields to their default values, right? Default values for string and default value for int. So you have to remember that if you have a class that has no constructor, or it has a constructor that doesn't initialize anything, you have to remember the default values of all these types. So we'll start with string because it's right here at the top of our list here. String, that gets initialized to what is called null. Okay, notice I'm not putting quotations around it. That's just null. It means basically nothing. That is saying to the compiler, hey, eventually I'll have a string, but don't create it yet. Okay, it's nothing. Okay, integers, they get initialized to 0. Doubles get initialized to 0.0. And we have to remember that Boolean gets initialized to false. These are the default values you must remember in your brain. Okay, memorize them because they will definitely come up later on in this course. So string is null, int is 0, double is 0.0, and Boolean is always false. Okay, so the question says, which statement reflects the action performed when the constructor is called? So when we call the constructor, it's basically saying what values are going to be going inside these two instance fields. Well, I just mentioned null is going to go inside here. Null is going here. That's an integer, so we're getting 0. So we should be looking for an answer that has null and 0. So A. The variable will be initialized to quotation, quotation. No. Okay, that doesn't match null. Quotation, quotation will actually create a string and put in like an empty string inside of it. Like that's a data thing. This is, I have no data. Null means nothing. So A is wrong right away. Don't even have to finish reading that. They all say 0. Initialize with 0. Number of axles will all be 0. So we know that it's going to be 0. So all of these things, we're going to be focusing on the null. B, the variable type will be initialized to null. Okay, the key here is that it's putting quotations around null. That means it's creating a string with null characters because this turns it into a string. So it's not a string. Okay, this doesn't have quotations, so no for B. C, the variable type will not be initialized, but the variable num_x will be initialized. No, it does get initialized. Strings get initialized, so C is incorrect as well. The variable type, right, we're talking about this one here, will be initialized to null. Ooh, that looks good. That's matching. Okay, and the variable num_x will also be 0. Okay, so we finally got a good answer. It's D, right? That's what it is. Null and 0 for primitive and strings. Okay. So let's go down to 13, move along here, getting closer to the end. Consider the following code snippet. Public class vehicle. So we have a vehicle and we have a constructor here that has a type. Okay, so it's taking in type, which is a string. So this is similar to the question we just had, but this time the vehicle constructor does have a parameter. And in here we have a ... So I'm assuming that this question might have something to do with the ... Okay, so we've got an instance field of type and the constructor that will initialize that value. So what is wrong with this code? Ooh, something's wrong with this. Yes. So A says the class instance variable type must be initialized when it is declared. So that's saying basically we should have written something here. That is false, right? That's the purpose of the constructor, to put something in there. So it can't be A. B, the constructor must not have any arguments. No. Number one, they're called parameters here. And number two, it can have them. We have the options to have nothing or have something. In this instance or this situation, we have something. So the keyword here is must not, so we can. So no, it's not B. C, the constructor must not have a return type declared. Ooh, so it's saying right here, we should not have this. And that is in fact true. There should be nothing there. Remember that constructors never return anything ever. They never return anything. Okay, they're basically like void. But it's one of those things that it's written, we don't want to write the same thing again and again and again, so it's just kind of made obvious. We don't even have to write the word void because it's so obvious that constructors never return anything, so we just don't write it. So you never write the return type for a constructor. So I'm liking the answer so far for C. That's a pretty messed up smiley face. But let's get on to D. The constructor's return type must be void. No, it must not be anything. We don't put anything here. Okay, so even though constructors don't return anything, we don't write the word void. So the only thing that still holds up after looking at all of them is C. So that's true. The mistake here is that string was typed. Constructors construct. They make. They don't return. Let's move on to 14. Okay, in 14, what do we have? consider the following code snippets. We got public class vehicle again. Wow, liking this class. String type, number of axles. Okay, so those are our instance fields. Public vehicle, so it's the same name. Oh, we just learned there should be nothing here, and that's right, it's correct. So there doesn't seem to be an error with our constructor. And we are initializing vehicle type and number of axles. Okay, so we'll pay attention to the data type of string and int, and that matches string and int. And it says, which of the following statements can be used to create an object of this type? So we're going vehicle and auto, so they're all starting the same. And remember, just very briefly, they're all the same here. This is the reference to the object. Over here on this side of the equal, this is the construction side of the object. Okay, so this side of the equals, or the assignment operator, actually constructs it, right? That's what the word new does. New says, okay, make this object now. And then the name of the constructor here comes in. The constructor is, okay, basically, how are we making it? What values are we putting inside that object? Okay, so this question is asking us which parts of these are actually going to create this object. Well, this part here is all the same. So we're creating an object of an auto. New is all the same. That doesn't help us, but the constructor call here is different for all of these. So basically, if we look at it quickly, it's basically asking us, how are we sending it data? Which one of these is correct? So if we look at vehicle type, that should be a string. So right away, B is no-go because 2 is not a string. These guys are strings. This one doesn't have anything. So we have string, so that's correct, and then we have an integer. That's not an integer, that's a string, and that's okay. So it looks like D is matching up. What's wrong with A? A is syntactically correct. That would create an object, and that would initialize string to null over here and an int to 0. But we're calling this constructor, right? The question is set up to be obvious, kind of like which values go inside this constructor. So the only thing that matches that is D with the SUV and a 2, because the data types match string and an int. So the answer for 14 is D. Okay. 15, we have consider the following class. Okay, we have an auto, and it's got make, model, and year, and then we have a make, a model, a year. So these are, and it's matching up with the name, so that's our constructor. And then, right, our parameter here gets passed to a make, and then a make gets passed into make, which is right here. So this is looking good for constructor. And then we have an accessor method down here, get info. And what does that return? It returns the year, which is here, concatenate a space, concatenate make, so whatever values inside make, concatenate a space, and then a model. So it's basically going to be like the year, the make, and the model with a space in between. Okay, so let's scroll down and look at our options here. Okay, get them to fit on the screen. Okay, so remember, we're looking for make, year, and model. So what do we have here? We have my auto equals new auto. Okay, so what's missing here is the type of reference, right? Remember, it should be the reference name and then in front of it the type of reference. So that's missing. So right away, I don't even have to finish reading this. This will never work, right? And if you look at B, C, and D, they all have that. So that's working for B, C, and D. Auto, my auto equals new auto. Okay, and then it says system out println my auto dot get info, which is a call to this one. And this new auto here, it's creating an object with a null inside the string. So remember, all of these are strings, so that would be null, null, null. Null, remember, is not an empty string. It's a nothing string. So if we tried down here in B to print it, it would get an error because there's nothing inside here. We have something called year, but it hasn't been initialized with an actual string that we can print out. So in B, the first line here is correct, but the second line would actually cause an error because there's nothing inside these guys, these three things, okay? So B is out. Okay, C, auto, my auto, new auto, Ford Focus 2011. Okay, so we got string, string, string. However, notice how it should be year, make, and model. So the make is Ford. The model is Focus. Okay, that makes sense. And then year is 2011. So those numbers seem to be matching. And what's our next line? It says my system myauto.getInfo. That is looking not too bad. So I'll put the smiley face next to it. And then our next line with my auto, new auto, 2011 Ford Focus. So it's basically the same thing as C, except the numbers are out of order. So just to double check, so we're doing like year, make, and model. And if we go up here, we have make, model, year. So we have to realize that even though they're strings, what their actual values represent are a little mixed up here. Here they match. Make, model, year, right? Make, model, year. So those three things, what they're actually referencing, are important. And what matches that is C, the make, the model, and the year. D is syntactically correct, except this would mean that my company that's making the cars called 2011, and it was made in the year Focus. That's not how we do things here on planet Earth. So the answer for 15 is C.